Okay, like I've told you before, in Algebra 2, and it's not just Algebra 2, it's all the classes after that, because right now in Algebra 2, they've been working on factoring again to try to make sure that their skills are good for pre-calculus. I don't know what it is with students in factoring. While you're doing it, I think that most people get it and they're fine with it, and then you forget. So anyway, we already talked about the GCF last week, but I want to go back over that, and I just kind of want to show you this chart a little bit. So these are some factoring strategies that we have. And the first one is to always factor out anything that is common. So we want to factor out the greatest common factor. And obviously my little box didn't fit that in there. But we want to look for the GCF first before we do anything else. And then after that, you're going to look to see if the problem has two terms. And what I mean by that is like a binomial. So this right here is considered a problem that has two terms. It's a binomial. Or if the problem has three terms. So if it has three terms, that would be a trinomial, so something like this. So if the problem has three terms, we're going to do this thing called rooftop. That's what everybody here at this school calls it, so I'm just going to go with that. And if it has two terms, the only thing that we're going to learn to check for is called a difference of squares. Do you remember those words from when you were in Algebra 1? Difference of squares? No. Okay, that's kind of the problem with factoring. It's just a lot of students forget. So anyway, always look for the GCF first, and then we'll see if the problem has three terms or two terms, and we'll go from there. Okay, so first one, I just want to review the greatest common factor. This is what we were doing last week, but I just kind of want to go back over it. So I'm just going to start with number 1, and I don't plan on doing all of these. What's the greatest thing that would divide into 5 and 10? 5. The greatest number that divides evenly into 5 and divides evenly into 10 is 5. What's the greatest number of v's they both have?
3.
The greatest number of v's they both have is v cubed. Okay, once you find your GCF, you slap a set of parentheses back behind it, and you figure out 5v cubed times what would give you what you started with. So 5v cubed times what would make 5v to the 5th? V squared, good. And 5v cubed times what would make a 10v cubed? A positive 2. And then at some point, and I don't know if we're going to get that far in today and Monday, probably not, you can factor what's left in the parentheses, but today I'm not going to mess with that quite so much. But sometimes we can factor what's in the parentheses and keep on going. But for right now, we're just going to stop right here. Okay, so I just want you to take a second and try number 4, and then see how well you do with that, and then maybe we can move on to a different kind.
Are you drawing a stick or something?
Well, last time I drew sticks, nobody wanted my candy.
I want candy. You can just call on me. Sticks just so 4 seconds. Can you just call on me and I can walk away?
Well, hang on. There's nothing exciting in here. Let's see if I can find something. A little bit of chocolate. Okay. Hopefully there's something in here you like. All right, I'm going to actually call on 2 different people to help me with this. So the first one is Masha. Can you tell me what your GCF is? Just the GCF.
For number 4.
For number 4.
6x cubed.
Good. 6x cubed. And then you slap your parentheses back behind that. You can come up and have something. Okay, and then Shelby, can you tell me what's in the parentheses? X cubed.
4x squared.
Beautiful.
Plus 3.
Very nice. That's it. And you can come up and get something as well. Do I have both of you?
No, just mine. Mine.
Yeah, I need both of them. Okay, so how are you feeling about the GCF? You feel good enough that we could move on? Okay, the next one I want to talk to you about is called a difference of squares. So first of all, when you see the word difference, what does the word difference mean?
Subtract.
It means subtract. If you don't see a subtraction symbol, then there's no possible way that it can be a difference of squares. So like when I wrote this down earlier as an example, there's no way this can be a difference of squares because it's a plus, not a minus. So if we ever have a problem that has two terms, what we want to check to see is if it's a difference of squares. This one I wrote up here, there's no way it could be a difference of squares. And if it's not a difference of squares, more than likely there's nothing I can do to it if there's no GCF. Okay, and then your perfect squares. Do you know what those are? Your perfect squares, if I say that word to you? 64 is a perfect square. What else? 121, 16. Okay, so here we go. So I'm just going to start writing a list of perfect squares. What's 1 times 1? 1. What's 2 times 2? 4. 3 times 3? 4 times 4? 5 times 5? 6 times 6? 7 times 7? 8 times 8? 9 times 9? 10 times 10? Okay, etc. I could keep going. So these are called perfect squares because if you take the square root of them, you get a nice little whole number, no decimal. Okay, other things that are perfect squares. Variables that have even exponents. So x squared, x to the 4th, x to the 6th, x to the 8th. So if a variable has an even exponent, then it's considered a perfect square as well. Okay, so what it means to be a difference of squares. You have to have a minus for the word difference, and the numbers surrounding the minus have to be perfect squares. They have to be something like what I wrote down over here. So let's look at number 1. Do we see, first of all, I should always look for a GCF. This has got a 1 in front of it. Is there anything that will divide into 1 and 81 evenly besides a 1? No. And do they both have x's?
No.
Okay, so there's no GCF, but you're always supposed to look for that first. Okay, second thing, if the problem has two terms, which it does, 1, 2. So the chart on the front says, if the problem has two terms, you want to see if it's what's called a difference of squares. So let's see. Is it a difference? It's got a minus. Are these perfect squares? Yes. My variable has an even exponent, and 81's in the list that we wrote. So anytime you find a difference of squares, this is how they factor. One set of parentheses has a plus. One set of parentheses has a minus. And then the square root of the first term goes here and here. So what times what would make x squared? So x times x makes x squared, so that goes there. And the square root of 81 goes here and here. So what times what makes 81? 9. So 9 and 9 go here. And the great thing about factoring is you can always FOIL this out, double distribute this out, and see if you get what you started with. So I just want to check that in our brains real quick. What is x times x? X squared. Okay, that's good. What's x times negative 9?
Negative.
A negative 9x. What's a positive 9 times x?
9x.
A positive 9x. What's a negative 9x and a positive 9x?
Negative 81 squared.
It's
Negative 81x squared.
it's 0. A negative 9x and a negative 9x and a positive 9x, those combine to give you 0. So that's why you don't see any x's in the middle, because this made 0 x's. There's nothing left. That's why you don't see any x's in the middle. And then 9 times negative 9 makes negative 81. And that's it. So all differences of squares factor two sets of parentheses, one with a plus, one with a minus, and then the square roots just go in the first and last spot. Okay, so looking at 2. First thing I always want to look for is a GCF. Is there anything that will divide into 36 and 121 evenly?
6.
Does 6 go into 121?
No.
No. Okay, so I look for the GCF. There isn't one. And then because there's two terms, 1, 2, I want to see if it's a difference of squares. So is it a difference?
Yes.
Okay, are these perfect squares surrounding the minus? So this is a difference of squares. So two sets of parentheses, one with the plus, one with the minus. Okay, what do you think the square root of 36d squared is?
60.
Yeah, 6d times 6d makes 36d squared. So those go in the first slot. And then what's the square root of 121? 11. So 11 times 11 makes 121. Those go in the back spot. Do you remember doing this? Does this seem familiar at all? Maybe? Yes? No? Okay. Number 3. First thing I always look for is a GCF. Is there anything that will go into 25 and 16 evenly?
No.
No? Do they both have W's?
No.
Do they both have Z's? Okay, so no GCF. So then I look to see, since it's 2 terms, 1, 2, if it's a difference of squares. Is it?
Yes.
It is. So 2 sets of parentheses, 1 with the plus, 1 with the minus. What's the square root of 25w to the 4th?
5w squared.
Good. 5w squared. So 5w squared times 5w squared will give you 25w to the 4th. And then what do you think the square root of 16z squared is?
4z.
4z. So 4z goes here and 4z goes here. And that would be our answer. Okay, I'm going to have you try the next 2 and then I'll draw some sticks. So try number 4, try number 5. And I'm sorry about my screen. I have students that keep messing with it in 4th period, so it's not working quite right.
Uh-oh. I think you need to give them his attention.
Well, I have several students in there that have a phone who can run my projector and Ladybug, and they keep jacking with it.
Break their phone.
They'll just turn it off while I'm doing something, and they'll turn it back on, and they can change my dimness, and they can change my contrast.
From
And
their phone?
yes, from their phone.
What's this app called?
Yeah, just go break their phone.
Oh, there's several of them that are able to do it, and so it's hard to find the one that's doing it.
What do you mean able to do it? They're sneaky.
Only certain phones do it. iPhones don't do it.
The Samsungs do, like Galaxy.
I wasn't going to announce what kind of phone.
I only know that because one of my friends has one who messes with the projector all the time.
Ah, yes. So anyway, so they messed with it in 4th period, and now it looks like this.
He's not
Yay!
a freshman.
Everyone who has an Android in your 4th period class break their phone.
I could possibly get in trouble for that.
I'll do it.
Are we ready?
Yes.
Not necessarily.
No.
Okay, Savannah, I drew you for number 4. Can you tell me what you think you would get?
7 plus z in parentheses, and then 7 minus z.
Very nice. Would you like to give your piece of candy away to somebody? Okay, I'll draw a name, and your piece of candy can go to Cooper.
Oh, no, I'm good.
Keep drawing.
Savannah's piece of candy can go to Autumn S. Okay. All right, next one. Craig, have you been paying attention enough that you want to try 5? Even though it looks so awful?
Want to do it now?
Okay. Moving on. Oh, Austin Mason,
Yep.
what do you think?
I think 13m4 plus 1 and 13m4 minus 1.
Ooh, I almost like that. Tristan.
Bang.
13m.
Colton C.
Can we just raise our hand?
Yeah.
No, I like the sticks. It keeps it fair. Don't you think that's kind of my point of putting people on the spot? Autumn S.
That 13m squared minus 1 and 13m squared plus 1.
Yeah, and quite honestly, I'm kind of glad she said it that way. It doesn't matter which set of parentheses gets a plus and which set of parentheses gets a minus. As long as one of them has a plus and one of them has a minus, it's perfectly fine. Okay? All right, number 6. First thing I always want to look for is a GCF. Does number 6 have a GCF?
True.
It does. What is it? 3. 3 will go into 3 and 3 will go into 48. Now, do they both have K's?
No.
Okay, so 3 is the only GCF. Now, whenever you find a GCF, you write it down and you slap a set of parentheses behind it, and you ask yourself, 3 times what gives me what I started with? So 3 times what makes 3k squared? And 3 times what makes a negative 48? What kind of 16? Okay, so this is the first time I'm going to cover up my GCF and try to keep going. So I'm going to cover this little GCF up. I'm going to look at what's in parentheses, and I'm going to try my checklist again. Does this in here have a GCF? No. And then does this have 2 terms or 3? So when there's 2 terms, we look to see if it's a difference of squares. Is this a difference of squares? It is. So since it's a difference of squares, it's two sets of parentheses, one with the plus and one with the minus. What would go inside?
K.
K and 4. K plus 4, K minus 4. And then Mr. GCF, shoot, drop him. So sometimes you have a GCF and then you can actually factor what's in the parentheses. It just depends. Okay, now this next guy. He's kind of confusing at first, but you should have done this last year, so I'm hoping that it will kind of ring a bell. These are the steps up above, and so I'm just going to kind of talk about these steps as I work a problem. And I have one of them completely worked out for you, but I think I'm just going to start from scratch. Okay, so looking at number 2. First, I'm going to look to see, does it have a GCF? Is there anything that will divide evenly into 6, 23, and 7? No. And then does this have 2 terms or 3? Okay, so on the front sheet, it says if a problem has 3 terms, we're going to do what's called rooftop. Do you remember hearing that word last year?
Yes.
Okay, so rooftop wants me to take this A here times this C here. So what is A times C?
Well, that would be 42.
Okay. And I know last year they probably did have you write 42x squared. I'm not going to even mess with the variables, so I hope that doesn't throw you off. I just think sometimes it's easier to not mess with the variables until later. So I'm just going to take the 6 times the 7, and that's a 42. And I know not every teacher showed it like this last year, but this is kind of how I'm going to show it. But what you would have done last year would be kind of similar. And then you want 2 numbers that will multiply to be 42, and you're going to want them to add to be this 23 right here. So I'm looking for 2 numbers that will, well, it's a highlighter. That's why.
It kind of hurts.
Sorry. I want 2 numbers that will multiply to be 42, and that will also add to be 23. Okay, so let's look. 21 times 2. So let's check. Does 21 times 2 make 42? Okay, does 21 plus 2 make 23?
True.
Okay, so those are the winners. So this is the way it works. I recopy this first term, whatever it is. So I'm going to recopy the 6x squared. Instead of using the guy in the middle, I'm going to use these 2 numbers I just came up with. So since this is a positive 21, I'm going to write plus 21. I just need to remember to put an x behind it because the middle guy has an x, so I need to put an x behind it. And then this is a positive 2, so I'm going to write plus 2. I just have to remember to put an x behind it as well. And then the guy that's in the back, I just bring him down. So the plus 7, just bring it down. So I just want to make this make sense to you. 6x squared, recopied. Positive 7, just recopied. If you look at the stuff in the middle, does this 21x plus 2x, is it the same thing as the 23x that was there to begin with? So I didn't change anything's value as far as that's concerned. I just changed its appearance. Okay, once you do that, you look at your first 2 pieces and you ask yourself, what's the GCF out of those first 2 things? What's the greatest thing that will go into both of those? 3x. And every time you find a GCF, you slap a set of parentheses back behind it. So 3x times what makes 6x squared? 2x. 3x times what makes 21x? A positive 7. Okay, then I'm going to look at my back 2 pieces, and I'm going to look to see if that has a GCF. Is there anything that will go into 2 and 7 besides a 1? Okay, so here I'm actually going to write a 1. And then do they both have x's? No. Okay, so here's a little shortcut. Whatever is in this set of parentheses will go in this set of parentheses. These 2 sets of parentheses have to be identical. So if this is 2x plus 7, so is this one. And I can double check to see if I'm right or wrong here in a second. Now, this is going to have to distribute to give me what I see in the step above. So what kind of 1 do you think that's going to have to be? A positive 1. So let's just double check. Does positive 1 times 2x make that positive 2x up there?
Yes.
And does positive 1 times 7 make that positive 7 up there?
Yes.
Okay, as long as this distributes to give me what I see up above, more than likely I haven't made a mistake. So you need to know these 2 sets of parentheses, they have to be exactly the same. And then the final step's very easy. Whatever is in both sets of parentheses, whatever is the identical piece, you just put that in one set of parentheses down below. And then whatever's left over, 3x plus 1 goes in its own special set of parentheses. And that's the answer. Now, I can FOIL this out if you learned that word last year, or I can double distribute this to check. So I just want to try to do this in my head real quick. Check it. What do you get if you take 2x times 3x? 6x squared, which is what I started with, so that's good. What's 2x times 1? 2x. Hold it in your head, a positive 2x. What's 7 times 3x? 21x. If you combine a 2x and a 21x, what do you get? A 23x, which is what I had at the beginning. And then what's 7 times 1? 7, which is what I had at the beginning. So you can always check your work. Does this process seem familiar to you at all?
Yes.
Okay, so we're just going to practice some more of these. Since you have already seen it, hopefully it doesn't seem as strange as it does when you first learn it. Okay, let's look at the next one on the back. First thing I always want to look for is a GCF. Is there anything that will go into 4, 5, and 6 evenly? No? Okay, so then the next thing I want to look for, does it have 2 terms or 3? 3 terms. So we're going to do this rooftop method. So I'm going to take my A times my C. What's 4 times negative 6? Negative 24. And I want them to add to be the B, the guy in the middle. So I want them to add to be the negative 5. So can you think, and this is the hardest part for most students, you need to find 2 numbers that multiply to be negative 24 and add to be negative 5.
Negative 3 and 8.
A negative 8 and a positive 3. So those are the 2 that work. They multiply to be negative 24 and they add to be negative 5. Okay, whatever the guy is in the front, I just recopy him. So I bring the 4x squared down. Instead of writing the guy in the middle, I use these 2 numbers over here. So this is a minus 8, so I write minus 8. Just don't forget to put the x back behind it. This is a positive 3, so I write plus 3. Just don't forget to put the x back behind it. And then the minus 6 that's in the back, I just bring him down. How do you feel about the first step once you get your numbers? You okay with that? Okay, so now I'm going to look for my GCF. So looking at my first 2 pieces of information, what's your GCF out of those 2 guys?
4x.
I heard 2x and I heard 4x. What is it? 4x. Okay. Once you find a GCF, you always slap a set of parentheses behind it. 4x times what makes 4x squared? X. 4x times what makes a negative 8x? A negative 2. Okay, once I've done the front half, I do the back half. So now I look at my back. What's the greatest thing that will go into 3 and 6? A 3. Do they both have x's? Okay, so I can't pull any x's out. And like I said last problem, whatever you put in this set of parentheses, you should put right here. So if this is x minus 2, so is this guy. Now, let's just make sure that this distributes to give what you have in the step above. What kind of 3 do you think this is going to need to be? A positive 3 or a negative 3? Needs to be a positive 3. That way, positive 3 times x is the positive 3x up above. Positive 3 times negative 2 is negative 6 up above. Okay, and the final step's very simple. Whatever is in both sets of parentheses, the identical thing, you write it once in its own special set of parentheses. And whatever's left over goes in its own special set. What's left over? 4x plus 3. And I can always FOIL this out, double distribute it out, and see if I get what I started with. If I get what I started with, then I should be good. Okay, let's look at number 4. I'm going to do one more with you, and then I'm going to have you guys try one. Number 4. First thing I always want to look for is a GCF. What's the greatest thing? Is there anything that goes into 2, 15, and 7 besides a 1? Nope. 2 terms or 3? So when it's 3 terms, we do this rooftop thing. So I take my A times my C. What's 2 times a positive 7? 14. Okay. And then I want numbers to multiply to be 14, and I want them to add to be the guy in the middle. I want them to add to be 15. So what 2 numbers will multiply to be 14 that add to be 15? 14 and 1. Okay. Can you tell me what to do? I recopy the very first term. So I'm going to recopy the 2x squared. But then don't use the guy in the middle. What do I use instead? Can you tell me?
14.
What kind of 14?
1x.
So it's a positive 14, so plus 14x. It's a positive 1, so plus 1x. And then I need to do one other thing here.
Bring down to 7.
Bring down the positive 7. Okay, so that's step 1 once you find your numbers over here. Okay, next thing. I look for the GCF out of the first two pieces. So what's the greatest thing that will go into 2x squared plus 14x? 2x. Okay, slap your parentheses down behind it. 2x times what makes 2x squared? X. And 2x times what makes 14x? A positive 7. Okay, then I look at my back two pieces. And what would you say your GCF is out of those guys? A 1. And I do actually have to write the 1. Can you tell me what's going to go in my parentheses? X plus 7. If this is x plus 7, this is x plus 7. They have to be identical. And then what kind of 1 does he need to be? Positive. So far they've all had to be positive, but sometimes this will be negative. Okay, can you tell me in my final step, what's in one set of parentheses? X plus 7. How about the other set?
2x plus uno.
2x plus uno. That is correct. It gets easier, don't you think, and faster once you know what you're doing? Okay, I want you to try 5. See if you can do it from start to finish. I'm so excited to see.
I know I can.
You wish you were doing this, don't you?
Oh yeah, I do.
We're having a lot of fun here.
I just want you to see it.
Well, Craig had a chance. He blew it. He blew his candy opportunity. It almost makes me want to eat. Oh yeah, the special dark chocolate one for Craig. Okay. Yes. Love it. Piece of chocolate going in my mouth.
That was really slow just now.
You can have one in a little bit. Are you guys able to find your numbers? Because that's sometimes the hardest part. Before you guys go too far, can you tell me what two numbers you found?
Negative 12 and negative 12 and Tara.
It's a negative 12 and 2. The reason the negative 6 and negative 4 don't work is because they multiply to be a positive 24. Okay.
Good. Good job.
That's okay, because I figured somebody might do it. I just have had a lot of practice.
Yeah.
No, I'm serious. It goes a long way. It does. I'm much smarter now than when I first started teaching. But it's because of years and years of practice.
So when you're saying something we know. That's what we're like, is it copper?
I didn't know that.
No, sometimes people don't realize that.
So you basically teach yourself.
Mm-hmm.
That's so cool.
Are you guys ready?
Yes, ma'am.
Is it too soon? Too soon?
What was the answer again?
I like the way you said it. You said negative 12
Okay, I'm going to draw a stick. We'll see if somebody... Oh, Cooper, it's you. Can you tell me?
No, I can't.
For crying out loud in a bucket, Cooper. Colton C., what's up with this? Beautiful. 2x minus 3. Come on up, Colton. Have a piece of candy. 2x minus 3 and 4x plus 1. Now, did any of you write it with the 2x here and the minus 12x here like you had these reversed? Did anybody have their 2x here and their minus 12x here?
Yes.
Because it is possible to have these turned around and still get the same answer. I mean, you should get the same answer. Okay, let's go down to number 6. First thing I want to look for is a GCF. Is there anything that will divide into 1, 1, and 56 besides a 1? No. 2 terms or 3? So we're going to do this A times C rooftop. Do you know what's in front of this y squared? You just don't see it? A 1. So that's my A, that's my C. So what's 1 times negative 56? Negative 56. I want him to add to be this guy in the middle. What's in front of that y? Oh, what kind of 1? Negative 1. What 2 numbers will multiply to be a negative 56 that add to be a negative 1? A negative 8 and a positive 7. Ding, 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 ding.
Whoever said that is smart.
Okay, so I'm going to recopy my very first term, the y squared. Instead of using the guy in the middle, I'm going to write a minus 8. Just put a y back behind it. This time they're y's, not x's. This is a positive 7. Just put a y back behind it. And then drop the minus 56. I'm going to show you something on this problem, so make sure you're paying attention once we get done. Looking at the first 2 pieces, what's your GCF out of those guys? A 1 y. So I can put 1 y or just y. Okay, y times what gives that back? Y minus 8. Okay, looking at the back 2. What's your GCF out of those back 2? A 7. What do you know needs to be in the parentheses? Y minus 8. So that goes there. And should this be a positive 7 or a negative 7? Positive. Okay, so final step. What goes in one set of parentheses? Y minus 8. What goes in the other set? Y plus 7. Okay, so I want to say something really important here. If everybody could just listen for a minute. This problem, do you notice how our answer ended up using the same numbers that we saw here? Whereas the problem up above, these 2 numbers were not the same that we had here. And the problem up here, these 2 numbers were not the same up here. But in number 6, these 2 numbers were the exact same thing that we wrote up here. The reason is because of the 1 in front of the y squared. So my point that I want to say to you is, you can do the long method for every trinomial that there is, but if there is a 1 in front, we could shortcut right to the answer once we get these 2 numbers. I could skip all this, put y here and y here, because that's what would make y squared, put the minus 8 there, put the positive 7 there, and be done. But I only get to do that if there's a 1 in front. If there's not a 1 in front, I have to go through the whole long rooftop process like we did in all these other problems. So let's look at 7. Does 7 look like it's a shortcut kind of problem? Yes. So let's just try the shortcut. So first, I'm going to take my A times my C. I'm supposed to look for a GCF, but I know there's not one. So what's A times C here? 32. What do you want the numbers to add to be? Negative 12. Okay, nobody blurt it out. I want everybody to think for a little bit, and I'm going to draw a name. I'm looking for 2 numbers that multiply to be 32, and then will also add to be negative 12. Nobody blurt it out. 2 numbers that multiply to be 32 that add to be negative 12.
Me has it.
And then I will draw a name. I keep drawing all these sticks with Kelsey on them.
Who was that?
Gavin. It was you. Were you paying attention? What 2 numbers multiply to be 32 that add to be negative 12?
It's the right answer if you're watching. Negative 8 and negative 4.
That's it. Come get a piece of candy. Negative 8 and negative 4. Okay, because of the 1 in front, I can shortcut straight to the answer. If this wasn't a 1 in front, I couldn't do it. So what makes x squared? What times what makes x squared?
X.
So x goes here and here, and then I just get to write these numbers down. This is a minus 8, so I put minus 8. This is a minus 4, so I put minus 4. Done. But you only get to do that if it's a 1 in front. If it's not a 1 in front, you have to work it out the long way. Okay, I know that you're going to hate me for this, and I'm really sorry. I'm going to give you just a few to do. So let me shrink this down for a second, and then I'll pass it out.
I have a really busy weekend.
Oh no, I'm not gonna make it too bad. I'm just gonna have you try 1, 2, 3, 5.
Can you send a text message?
7, 8. Okay, that's it. I'm gonna pass them out, and then those are the ones. So 6 problems. That's not too bad. 1, 2, 3, 5, 7, 8. This wood what?
Smash wood.
This wood! Please, don't give me some problems. I don't want to look at it.
So 1, 2, 3, 5, 7, 8. Well, do it right now, you guys have. You have like 5 minutes. No, you don't. Do you think you can
Happy when I got the platinum medal. I'm just like, okay, I'm gonna be weird.
Not too big. Oh. Yeah, but guys, you have like 5 minutes right now. You should be able to get several of those done. Do any of you want it just for fun? Just asking a question. Jeez Louise. I'm going to have to... Jeez Louise. Jeez Louise.